Merry Christmas! So today is Christmas. I was going to do a couple of Christmas themed things for this channel, but I haven't actually finished my exciting Christmas tree yet that I was going to make. So we're not going to do that project, but we can talk about one little thing. So this is a bit out of what I've started off doing beforehand with the little LEDs and beginner stuff with breadboards. So this is a slightly more advanced topic. And this is going to be an Arduino project. So our first one here. So we're going to talk a little bit about the coding for it as well. So this is a coding and electronics talk. It's probably going to be two parts because there's quite a lot to this. But anyway, I went to the supermarket before Christmas and they were selling Christmas lights on special. These little LED things. You can buy them everywhere, of course. These ones are star-shaped. They're pretty unexciting because when you turn them on, they're white and they're pretty dim. But the important thing is they just do nothing. They just come on and that's it. And it's not very exciting, which is it's fine. Like obviously, how does that look? Okay, all the lights are off. It's all nice and bright. Very Christmassy. If these are on a tree, this would look good. I'd feel in the mood for Christmas. Oh my goodness, what's on my hands? Got bitten by some mosquitoes today. It was very annoying. So anyway, that's not what we're talking about. Maybe mosquitoes would like this though, so I'm not going to go outside wearing this around my neck. But anyway, so these are these lights. They don't do anything. So the project we're going to do is we're going to try and make these lights do something under the control of a microcontroller. And so let us begin by turning the lights back on. For a second. Maybe I shouldn't have done that because I'm just about to show you a finished model of what we're going to do. So anyway, we're going to put that one to the side. We're going to work on this one in a minute. So we'll come back to this one. So hopefully this one's the actual prototype is a mess. So here are some more lights, and they're a mess. They're all over the shop. They're like that. Okay, believe it or not, there's actually two sets of lights in here. One of them has little reindeer on it, and one of them has lights. And so these ones are the same brand, but these ones are slightly more exciting because they're multicolored. And so over here, bringing it in from the side, is a terribly badly wired up set of components. But here is a Arduino clone board, or an original. I think it's a clone. And when I plug it in, and there's a little bit over here, and we're going to talk about this. So this is just a bit that I've made up, which is basically all the extra bits we're going to need to get this to work. And I'm using banana clips. They're called banana clips? No, they're not. Crocodile clips, alligator clips. Not a fruit, but a type of thing that eats people. Or eats things. Well, everything eats things. That's a thing. Alright, so here we go. We'll turn it on and the lights come on, and we'll turn the other lights off again. So, and hopefully you should see. So these ones, they fade in, and those ones fade out, and then those ones fade in, and then the other ones fade out, and then they all sort of like do this, and then after a little bit, they go through this little phase where they do that thing, and then they go back to the smooth fading. So the trick with this, of course, is now that we've got this set up, you could actually program whatever style you want, and you could have more than two sets if you'd like. So that's kind of fun. Like, it's a really easy project to do. It's just a bit of a mess with the wires, so you really want to do this properly. I have all these alligator clips because I didn't want to actually chop these things up. So I mean, ultimately what you should do is cut the wires and get rid of the battery boxes because they're not actually being used. So let's put the lights back on. Let's turn this off for a second, just by unplugging the thing. So now it's off. We'll move these out of the way for a second, and we'll just focus on here. So in actual fact, these battery boxes, when I do this, are not used. There are no batteries in here. All the power came off the Arduino, and we didn't need these anymore. So as I said, you could just cut the wires here. The only thing to pay attention to is, I'm just going to move the camera up, there's actually a little resistor there, hopefully you can see that. I measured it, it is a 12 ohm resistor. These are all wired up, I believe. Sorry, I have my little piece of paper. Kind of like this. So, in this case here, where did I put? Oh my goodness, I just literally had a pile of them. Here we go. So this is actually 12 ohms, and it's designed for 3 volts. So normally when you have your resistors, you'd have your current limiting, when you have your LEDs, you'd have your current limiting resistor for each of these. You might do this in your normal project, but they've just had one because there's a whole bunch of these things, and this is quite a low resistance because the current is going to get split up between each of these LEDs. So there's 10 LEDs on each lot, so there's 20 there. So that's 12. And so we could probably do the calculation. Let's just do the calculation. I'm going to turn it on the side. So we know, what do we know? Do we know what the voltage drop is? I think we're going to have to get some batteries out. I'll take them out of this one. So give me a second. Actually we won't. We'll just know that this is calculated to make sure that the current that goes through here is not too high. It's just the right current to go through here. If you had more LEDs, this would get lower. If you had less LEDs, this would get higher. That's pretty much you need to know. So you should already know that kind of stuff if we're doing this project. But if you don't, that's kind of what it is. All we really care is that I put 5 volts here. 3 volts go in here. When we finish, 5 volts is going to go in here. 3 volts go in here, and they go out the other end there. So in and out. There we go. This is our ground down the bottom, but it's not. I didn't label it as ground because I'll show you in a minute why. That's the printer test page. We are going to use a transistor. So I've drawn it 2 different ways here to control the LED. So this is the only tricky part with this, other than the programming. And the reason we're going to do this is because the poor little pins on this thing here, the poor little outputs on the microcontroller, the Arduino, are not powerful enough. Well, they won't like it if you try and suck up as much current as you can as these things would if you just connected them directly. So this thing would get damaged if you were to plug this in and use this to say output 5 volts along one of the outputs. So here's the outputs here, these 2 wires here. Not very easy. We might zoom in just a little bit, not too much. I seem to always get confused about that. I notice other people use a digital zoom. Maybe I should go with that. But anyway, the point is, so there are two inputs here. Now we could just say, well, I'll set them to 5 volts output, set them high, and we'll just throw that down the pile of LEDs, and because that's what you do with one LED and it works fine. But that won't work too well. This simply cannot provide enough current to do that, and will probably damage it. So the lights won't come on, and this will just be like having a very bad day. Okay, so that's why we can't do that. So we can only put out like 40 milliamps. So I wish it was okay. That's probably where we should have gone through and done the calculation for what the actual current going through the overall current going through. So the current going through each individual LED is of course easily capable of being provided by, we can assume, by this little thing here, because we do little LED things with these all the time. So 1 LEDs we're fine, maybe we can get away with 2, but we can't really do 10. And we want to do a more general solution to this problem, so we're going to look at using a transistor to do this. So here I'm using an NPN transistor. You can tell because the little arrow is pointing outwards, so never pointing in or something is the way to remember that this is an NPN. I will talk more about these this is a bipolar transistor. I actually did not use, I used these ones here, which are bipolar transistors. You can't see it. They're in that package there. These are, what are they? They're labeled, I think they're TIP120s. So they're Darlington power transistors. But for now, we're just going to say they work the same way. They just have a very high gain in comparison to simpler transistors. But I'm going to actually try it with a simpler transistor. So I've got my little box of 222s, which are very common and very cheap. And I looked them up, and they can provide like half an amp. I'm pretty sure this thing is not sucking up half an amp. So we're going to try it with this one today. But I use the power transistors because they can take a bit more. But they also have a slightly different characteristic because they're these things called Darlington transistors, which, if you don't know, just means that they're two transistors combined together. So one transistor feeds into the next transistor. I'm not going to draw it. And so if you put a small amount of current into the base, which is that bit there, this is the controlling bit. This is probably very small. This will send out, this will allow a much greater amount of current through than if you just had the one transistor. So this one allows, basically sends them into the base. That one allows a bit of current to go through, but that's more current that's going into the base of the next transistor, which is the one that's actually doing all the work from the point of view of the outside world. And so I've wired them up in this sort of way. So this is the common emitter way of doing it. So there's basically, they will go out to the ground like this. But the point is, the thing that we're working with, that we're trying to turn on or off. So this is just talking about using a transistor to turn something on or off. The thing that I want to turn on or off is up above, is how I'm looking at it, up above the ground. So it goes from the 5 volt through the thing that we're trying to turn on into the transistor and then down to ground. So this thing is being used to sink current. So it's when it's on, it will sink current to ground. When it's off, it won't sink current to ground. So let us go and see what happens if we build this. So the trick that is, I always forget. Sometimes it's useful to have these things. Sometimes, half the time, I've usually got one of these stuck in your multimeter, so you can test which is the collector, the base, or the emitter. So I'm just going to label this before just so you don't. So this is the collector, the base, and the emitter. So collector, base, emitter. I've drawn a box so that I know which is which, because they're different for different types of things. So in this case here, it goes looking down on the top with the pins. It's collector, base, emitter. So I'm going to remember that, and I'm going to put this in here, and I'm going to use little power supply thing. So we're not going to use the microcontroller just to begin with, because we're just going to see if it works. Alright, so I'm going to put that there. And I'm just going to I'll abuse these things. I'm beginning to hate these wires, actually. They're actually kind of terrible. So let's just look at my little picture. So my collector is the thing that's going to go, between. So the thing that we're turning on or off is going between this wire and the 5 volt power supply. Let's just use better colors. So I'm going to use yellow for that one, so that I know, and then I'm going to use this one to go. That's from the 5 volts there. So the trick is, I've actually tested, these things are fine when you run them off 5 volts. They're just a bit brighter. So that's good. It's not going to blow it up, even though they only use 2 AA batteries. So the next thing, what have we got on my little picture? So the one in the base is in the middle. So that's going to be my controlling wire. So I'm going to leave that one. Actually, we'll use this. So the one on the end is the emitter. So that one's going straight to ground. So I'll just cross it over to here. So now we've got that. And now we have to get this thing. So here we go. I'm going to use this one. Where did I put my screwdriver? I'm going to quickly undo this. So we're undoing this, and it's popped off. Look at that. And take out these two batteries. We're going to pop the cover off. So I'm going to try and avoid on the channel doing too many teardowns of things, because really I don't, not such a big fan of teardowns. We will look at some vintage computer stuff and bits like that. But again, you can see it looks pretty much the same. So there's that 12 ohm resistor, and here, so we are just going to use more alligator clips, crocodile clips. What should I use? Because I haven't got the right colors today. So I'm going to say that yellow can be, yellow is more like green, and green's more like ground. So yellow can be ground. Alright, so the positive is the positive 5 volts is going to come in through here onto the positive connector on the battery box. So I'm going to plug this into here, and then it's going to come out the other end, and it's going to play. Well, that's good. I've got yellow and yellow. That was well planned, and it's going to go into the collector on my transistor. So now this is my. I've wired this up to go in between. So that's what I've just done here. Obviously the switch has to be turned on before this is going to do anything. Let's just get one more wire. So we don't want to put too much current into our base, so we're going to use a transistor. So we'll start off, I've got these 4.7K ones. So I'm going to put a, what's the easiest way of doing this? I want to make it look neat. Okay, so we're going to put one red one. Actually, we're not going to use that. Not going to use that, not today. But we'll get one of these wires, and we're going to bring it across so that it's out of the way a bit, and onto the other side of the board. Alright, I think that's alright. Okay. This may not work, of course. We may have to get out the power transistors, which are just over there. I have them all ready to go, so don't worry about that. And this is the newer, not so easy to plug in, but not too bad. So there we go, we've got 4.7, and then we're going to get 5 volts from here, and we're going to put that into there. So basically 5 volts going to go over this wire into the resistor, slow, and then it's going to get a little bit of current coming through here. The voltage is over 0.6, so we'll talk more about transistors in another video, just to get why it all works. But all we have to care about is that we're putting in a small current into the base, and that's going to allow more current to be sunk down to ground when we turn it on. So when we turn this on, the lights should all come on, and hopefully it won't blow up. Now where did I put that 9-volt battery? Here we go. So this is the moment of truth. If not, as you may know, I have a lot of these transistors, so that's fine. And that didn't work. Well, that's the most unexciting thing of the day. What have I done wrong? Oh, I forgot to switch it on. Alright, so there we go. It's not. It's now working. Lights off for a second. So the lights are off. And now if we disconnect, so this is the wire here that's connected to 5 volts. If we take that one off, then everything turns off. But everything else is still wired up. So this is the trick, right? So this thing here is not drawing a lot of current. So we'll turn the lights back on. So the reason we've done all of this is that this wire, this path here doesn't require much current, so we could then use this, if we were plugged all of this in, as an output on our microcontroller. And that's not going to be a problem because not much current needs to go through here. In fact, we could work it out if I had with my calculator gone. Oh, I've lost the calculator. We should do at least one calculation Seriously, like I literally just had it. It was sitting right here. Ah, that's what you get when you organise things. Okay, well we'll write out the equation and then we'll come back to it. So just for practice, how much is going through there? Well, we know that this is a 4.7k, so that's 4, I'm going to write it out this way, 4700 ohms. That's how much is going through there. And we're going to pretend that the entire 5 volts goes through there for a second, just to keep the maths right. It's not going to. What's going to happen is that it's going to be roughly 5 volts minus 0.6, which is what is needed to get through the base and down through the emitter to ground, to turn the whole thing on. But we're going to say that there's 5 volts going through. We'll just test that. Let's just test that before we go saying silly things. We'll just put this back on and it's going to turn the lights on. I said it's going to turn the lights on. It's not going to turn the lights on. Oh, what have I done now? Well, that's depressing. Oh, the thing popped off. That's the thing with alligator clips. They always just pop off when you least expect it. Okay, so there we go. Let's just test. There should be about 4.4 volts going through over the resistor. So we'll just test it. There's 4.4. I don't know if you can see that. I'll just pop that over there. So we test it going across. This says there's 4.27, which is close enough, right? I'm just going to test. It says there's only 4.26 going across the whole thing. That's a bit strange. Okay, so it's not putting it's not somehow getting a whole 5 volts across there. So that's what you would expect. So the resistor has about 4 point something volts going across it, but we're just going to pretend it's 5 volts. And this is going to, I think, overestimate the actual current. So we've got 5 volts with a terrible V. 5 volts with a terrible V. So V equals IR. So there we go. That's my basic equation, and then I can work out that, because I can do algebra really easily, I equals V divided by R. Right. So in this case here, it's going to equal 5 divided by 4700. Maybe we should actually, let's just say it's 4.7 volts, so that's still overestimating it. And so that's going to be, oh my goodness, what's it going to be? It's late, so I'm going to write this as 4.7 over 4.7 times 1000. That's right. So 4.7 times 1000, they cancel out. So that's 1 over 1,000th. So that's 0.001. That's right, isn't it? Who knows? It's slow enough to not worry about. So that we've done that. And I'm just going to lost the lid on my felt tip pen. Oh, crazy. So actually we might just finish it there for tonight. And then tomorrow night, or maybe we'll just do the next video. Oh, look at the mess I made at my beautiful drawing. Felt tip pens. The other felt tip pen was much better and didn't go through the page. So anyway, we've got this part, we've worked out this, we've done this, we've wired it up on this little board now. And so all that I did is I did a very similar situation, except the 5 volts on my finished model is coming straight off the Arduino. So that's a little bit risky because that can only, I think, provide like something like 0.800 milliamps or something, I think it is. Okay, I should have just said this. It's 1 milliamp. All right. So 1 milliamp is going through, which is the Arduino is happy to supply for the base. I'm pretty sure it's not using more than 800 milliamps or 400 or 200 milliamps, I need to check what the 5 volts is, because that's the regulated 5 volts that's coming out of here. You could always just use it if you did it off. It's fine, it hasn't broken yet. So, but you should check how much you can get off there, and if you can't get enough off there, you'd have to do a slightly more cleverer power supply situation. You could always just run it out of the 9 volts, straight out of the 9 volts. So if you look on here, it does have a voltage in. So here's the voltage in pin on the bottom here. So if you run it out of the voltage in pin, you actually get the 9 volts that go into here. So with that, you probably, these things are going to be pushing it with your 12 volts. So you'd have to adjust the resistance so that the current isn't too much going through these things. And it's a little bit wasteful, but then it's all going to be wasteful because it's going through a regulator. So the best thing maybe would just be to plug it straight into a USB cable and then take the voltage in, which will probably still be 5 volts, and then you'll be happy. Right, but anyway, we'll finish that. So this is the basic model. Very, very simple. And now the next video we'll just talk about the programming, and then that will be it. So yeah, so thanks and Merry Christmas.